So a soft rocket toy is a toy with no engine that is launched by a quick burst of compressed air. So this is what it looks like. So we're looking up on the board. Okay, so discuss with a partner what you notice and wonder. So take 30 seconds. So now we're going to make a prediction. How high do you think the rocket will be after 4 and 5 seconds? Enter your answers into the table. Okay. So what do you think it's going to be? Go, just type it into the table because I can see your responses. What? Yeah. All right. So if I go in here, all I ask you to do is type it in. Okay. So somebody said 160 and then 175. Okay. All right. Let's go ahead and look at Maya's work. Okay. Maya's strategy. Maya noticed that there was a quadratic relationship between the time and the height of the SOMP rocket. Describe what she did to find the heights at 4 and 5 seconds. Okay, so describe what she did in words, how she got the heights between 4 and 5 seconds. Some things that you said was she found the difference between the numbers first and then found the second difference. Okay. All right, so she found the difference and then she subtracted those differences, right? Good. Okay, on slide number 4. I know, I can. Okay, so here is a new rocket. The table shows its height at various times. How high will this rocket go? Okay, so think about how Maya used her strategy. Remember, she found the difference between the first. So what's the difference between 0 to 45? 45. Okay, what is the difference between 45 and 80? 45. Okay, so there's a difference of 10, right? Okay, so on this next one, there should be a difference of 10 here, which means this should be 25, which means that this would be 105 at 3 seconds. Well, we don't know if that's the highest it'll go. We'll try it again. So between here and here, this should be what, 15? So 105 plus 15 is 120. If we find the difference again, this is going to give me 10 between these, which will be 5. And this will be 125. And then on the next one, this will be -5. So we'll actually subtract. This will go back down to 120. So I'm subtracting them. 125 minus 20. 120 is 5. All right, so here it is again. Here's visual. So we go 45 minus 0 gives us 45. And then 80 minus 45 gives us 35. And we keep doing that. And then we find the difference between those. These all have to be the same number, though, in order for it to be quadratic. Okay, so it should be 125. All right, moving to slide 5. Moving to slide 5. Here's a rocket from the previous screen. How many seconds will it take for the rocket to touch the ground? Take a second. Take a second. Try it. Well, it took 5 seconds for it to get to the highest point. So how long should it take for it to hit the ground? 10. Okay. Okay. A new SOMP rocket is launched from the top of the building. About how many seconds will it take for the rocket to touch the ground? Take a second. Well, I'm seeing that majority of y'all are saying between 6 and 7 seconds. Okay. All right. I know. I'm keeping this moving. Not taking too long. Ivan made a graph to help him think about how many seconds it would take for the rocket to land. Why do you think Ivan drew a parabola? Parabola is the shape of a quadratic. And then how do you think he used his graph to determine when the rocket landed? So take a second, answer those 2 questions. So what y'all put was because it shows the height and time. It shows the height going up and down. by checking the maximum height and seeing how long it would take for it to fall. Okay, answers. All right, slide 8. Okay, on slide 8, it says, click on each parabola to see the stomp rocket launch. Discuss with a partner what is the same and what's different. So here are the different graphs. I mean, you can literally hit try it. Okay, you can try the next one. And then you can try the next one. Okay, discuss with your neighbor what's similar, what's different, and go. 1 minute. Slide number 9. Okay, you're invited to explore more. Yay. How many seconds will it take for this rocket to reach its maximum height? How long will it take for it to reach its maximum? Y'all are all answering. So some of y'all are saying like 6, some of y'all are saying 5 and 6, somewhere in there, right? Okay. I know, I'm the worst. The table in the graph shows the height of a stomp rocket. Number 1, write a question about the rocket that you can answer using the table. Number 2, write a question about the rocket that you can answer using the graph. So you're coming up with 2 questions. One is going to be about the table, one is about to be the graph. So take a second, write that. Okay, somebody said, how many seconds will it take to hit the ground with the table? Somebody said, what is the maximum height of it for the graph? Okay, cool. All right, slide 11. Thanks. You're welcome. Okay, the table in the graph shows the height of a stomp rocket. How high was the rocket at 5 seconds? How long did it take for the rocket to land? You need to answer these 2 questions because on your test, it's gonna have something very similar. Okay, some of y'all be putting crazy numbers. Some of y'all said 240, and then majority of y'all said 8 seconds. Yay! Good. Okay, so really quick, let's talk through that. For the 8 seconds part, so how long was it in the air? You would just look at this graph, and you would look at the distance over here, right? Not y'all changing y'all's answers. Okay, so for the height after 5 seconds, well, we could have found the first difference. The difference between this is 112. Okay, help me with math. 80. And then what's the next one? 40. All right, what's the difference between here? It's 32, right? Am I making that up? No. All right, the next one is 32, right? All right, on this one, the difference between here has to be 32. So that means that this is going to be 16. And then that means that this is going to be 256. And then on the next one, it's going to be negative 16. So that's going to be 250. Nope, 240. Yeah, 240. Math ain't mathin' today, guys. Apologize. Okay, so what's our highest? 256. Okay, don't just look at the table. The table continues down. Does that make sense? Table continues down. So it's 256 as our highest. Okay, take a moment. Try slide 12. How well did you understand this? So now it's your turn to make a parabola. Drag the points. Hey, drag the points to see what kinds of parabola you can make. Once you make a parabola you like, continue on to the next screen. So make a parabola, and hit block parabola. Do it, do it, do it. Hurry up. Okay, good. Okay, number 3. Amma says her parabola turns around at 3. Select a parabola that Amma could be talking about. All right, so majority of y'all said either D or A. Okay. Okay. So most of y'all said D or A. Okay, so some of y'all said A because of here. Some of y'all said D because of here. Good. All right. Number 4, vertex. I'm not telling. Okay, mathematicians Call this turning point of a parabola, a vertex.
No.
I promise I'll tell you in just a second. Okay. It's called a turning point, so a vertex. This is also called a max or a min. So drag the point to make a parabola with a vertex at -5, 1. -5, 1. You could also make another one. Okay. So looking up at the board, these are all of y'all's combined answers. Look at it. So pretty. All right, on number 5. Katie says her parabola has an x-intercept at -2, and it looks like a smile. Drag the points to show what her parabola could look like. Again, there's multiple answers. So at x-intercept at -2 and looks like a smile.
That can't be a smile. Oh, what is this?
So this is what all of your combined answers look like.
Oh, what is
So all of y'all are putting it through this x-intercept at x equals -2. Good. Concave up versus concave down. So instead of saying it looks like a smile, mathematicians say concave up. Instead of saying it looks like a frowny face, mathematicians say concave down. Drag the points to create a concave down parabola with a vertex at 4, -2. Take a second, try that. So frowny face with a vertex at 4, -2. Okay, so I got something that looks like this. Ta-da! Okay, so y'all got very similar things. All right, on slide 7, it's time to make some parabola art. This was actually pretty cool in our last class. We had some cool things. So what you're gonna do is drag the point to make parabola shapes. And once you make a parabola, you can press capture parabola, and then you can move the next one and make it different colors and move it around to make a picture. Take about 4 minutes to create a picture. Hey, look at this real quick. Boom. Look at it. That's rude. Okay. Nico did something like this. Oh, look at Braxton's. Boom. It looks like a Wi-Fi thing. Oh, look at this one. Yeah. Oh, y'all are pretty creative. Look at y'all. Flying where you at. It kind of looks like smiley face, but it's got like a face kind of to it. I like it. All right. So going to slide number 8. I know. Manual made this design using parabolas. How are these parabolas alike? Describe as many similarities as you can. Take 30 seconds. Go. So a lot of y'all said that the parabola is facing up, that they're all blue. The parabolas look similar. They cross the x-axis at the same. Okay. Some of y'all said that it overlap. Okay. Good. Good answers. Okay. All right. On slide number 9. Try to make a parabola with 0, 1, 2 x-intercepts or y-intercepts. Okay, go ahead and take a moment. Fill that out. Good. Okay, so Cecilia gave me this. All right, how many times did it cross the x-axis? How many times did it cross? No, 1 time. Okay, how many y-intercepts does this have? 1. Okay. All right. If I have something like this one, okay, how many x-intercepts do I have? And then how many do I have for y? Okay, could I ever have like no x-intercepts? No. Yes, I could. Does that work? Yeah, but I would have 1 y-intercept. I would always have 1 y-intercept at least. Nope, I would always have 1 y-intercept. Yeah. Okay. All right. Lesson synthesis. Describe the graph using vocab from this lesson. So what vocab do we have? We have the x-intercepts. What does this point call up here? The vertex. Is it facing up or down? What word did we use there? Concave down. Okay, go ahead and take a moment. Describe that. So I like what Nadir wrote. This graph is a parabola that intersects twice on the x-intercepts and once on the y-intercepts. What else could he have written on there? Concave down. Okay. Somebody said the graph is decreasing. Yes, it is decreasing at some point, but it also is increasing. Okay. Somebody else said that the vertex is at -1, 4. Good. Okay, so we got some vocab. Go ahead and take a moment. Drag the points to make this parabola. It needs to be concave down. Needs to have a vertex at 5, 3, and then an x-intercept at 2, 0. All right, so looking up at the one on the board, this is what you should have gotten. Ta-da! Okay. Questions on this? Okay. All right, go ahead and fill out slide 12. Go ahead and fill out slide 12. Okay, so here are the robots that the 4 other groups of students built. There's a competition that awards a prize to the best robot. How might they decide which robot is best? How might they decide which robot is best? How, somebody said how high? Okay, what else? How far out does the robot go? Anything else? Okay, so here are the prizes. Highest launch, farthest launch, cutest robot, and strongest robot. So you're going to use that information on your worksheet to award as many prizes as you can. So on the back, there's a table, an equation, and 2 graphs. Okay, what I want you to do is figure out who is the highest, the farthest, the cutest, and the strongest, and then pick them and put them at the bottom. Okay, I'm going to give you about 12 minutes to work with a partner on this. Okay, and then we'll talk about it. So go ahead and get started. So on here, you should have found out that the maximum height of A robot was 21 feet. Okay, maximum height for B would be 4, maximum height for C would have been 20, and the maximum height for D would be 16. Now, maximum distance would be between 8 and 9 for the first one, 2 for the second, 17 for the third, and 14 for D. Now, highest launch for the robot would be robot A, farthest would be robot C, and then cutest, what did y'all come up with? B. Because it's shaped like a B? Yeah, all right. Strongest robot? D. Why did you pick D?
Let's go.
What does robot D look like? Oh, okay. Makes sense.
What?
Okay, cool. Questions, comments, concerns?
No.